Hello everybody. So we will now continue the process of drawing the McCabe Thiele diagram, and last time we stopped at the point where we were able to plot the top section and bottom section, and this is what we got at the end, and we changed the parameters and we're able to see that the code works for different values of each parameters that we have. So what we're gonna do today is to start uh, to draw the top section stages. I like first to go through the way we will do the plotting so that we understand what's going on here. So I'll just go to my Excel sheet that I used to plot before or do the same thing before on Microsoft Excel. I'll put the links to the videos that I used to do this work in the description. And what I did is that I put 3 points for each stage. So actually the stage is consists of two lines, as you see here. The stage is a horizontal line and vertical line, and the horizontal line consists of 2 points, 1 point here and 1 point there, one on the operating line, one on the equilibrium curve. And then the second line consists of 2 points, the one that was the second on the top line, and then another point on the top section line, on the operating line. So this is what we do, and then the second stage starts after or at the point where the first stage ends, and the third starts at the point where the second stage ends, and so on. What you need to keep in mind about these points, and this is what will make us able to plot actually, is that the first line has 2 points that have the same y, the same value of y with different x. So I know the y here and x here are xd and xd, and then this point has the same y as the first point. And the relation between x and y here is the same as the same equilibrium relation that we used to draw the graph in the beginning. So I can get the value of x here from the equilibrium relation. Of course, we know the equilibrium relation as y as a function of x, which is this relation. But you can, with some mathematical manipulations, it's not hard. You can get x as a function of y, and this is what we do here. I use x as a function of y to calculate the value of x that satisfies the equilibrium relation. The same thing here, I calculated this x, which is gonna be the same value of x here, and the y would be different because the y satisfies the top section equation, which is something we already know before. So this is what I'm gonna do in Matlab now. So I'll go back and forth to make sure that everything is clear. So to draw the top section line, we need to define the 3 points. Each point consists of x and y, so I'll define six parameters. The six parameters, I'm gonna call them x top 1, which is the x coordinate of the first point on the top stage, which is gonna start with xd. So I'm gonna draw the first stage first, just to make sure it's working, and then we'll see how we can let Matlab do the work for us. And then the y top 1 equals xd. Then I know I said this point has the same y as this point because it's a horizontal line. So y top 2 equals y top 1. And I know that the relation between x and y here is the equilibrium relation, so I can use this relation to get the x. So I'm gonna say that x top 2, I can save it as a function handle, so I'll say this is x equilibrium. It's a function of y, which is y divided by alpha plus 1 minus alpha multiplied by y. Okay, so I can use it now. So I would say that this is this equals to x equilibrium of y top 2. So I'm now done with the first line. I have the coordinates x and y, and then I'm gonna go for the third point, which is has the same value of x as the second point, which is x top 2, and the y top 3 is gonna satisfy the top section equation, which I called as top section. So I have it as a function handle here, which is gonna save me some time, of x top 3. So now I should be ready now to plot. So I'm gonna plot the first line. I'm gonna make them red so that I can easily tell that this is the top section. It's gonna start with x top 1, end with x top 2, and this is gonna be y top 1, y top 2. And I'm gonna take a copy of this to draw so the first is the horizontal line. This is gonna be the vertical line, which is gonna be from 2 to 3, and this is gonna be from 2 to 3. So I should be now good to go. So if I run the file, there's something here but I cannot see it, so I can make it easier for me by going for a small value of xd. So this is exactly what I'm trying to do. So it has done the horizontal and vertical line, and I know that this is the first stage. Okay, so what I need to do now is to repeat all the steps again and again and again until I reach the point where I'm sorry, where this point gets past the x and y intersect. So I need that this line would go something here, which means that this point should be greater than the x intersect. So this is the condition that I want to keep going until it's not satisfied, which is x top 2 is smaller than the x intersect. And to do this, we need to go for looping, and since we have a condition, I go for a while loop. To start the loop, I will start it from here because I should have a point to start with, which is here. So I need to have a point to start the looping with to do the checking on the very first time. So I would say while x top 1, let's keep it and then we'll come back to it. It's greater than the x intersect. Then this will happen. I'll keep tracking what's gonna happen and then see how we can fix any issues that may show up. So it's gonna calculate the y, the x top 2, x top 3, and y top 3, do the plotting. So this is exactly what I need to do, but it's not gonna repeat anything because the value of y top 2, x top 2, x top 3, y top 3 are not gonna change. And I need to have in the while loop to have this parameter changing so that it's repeating the values and reach a point where the looping will stop. So what I need to do, or what I did here, is that I put the first values on the second stage. So this is the first stage, the first 2 points on the first stage, and then the second 2 points, which is this line and this line. What I did here is that I got this point as the last point of the first stage and this as the last point on the first stage. This is what I need to do here. I need to have x top 1. It's gonna be a new. So I've already plotted them. So I'm done with the stage. So I need to change the value x top 1 to be equals to x top 3. And this is where I'm gonna start the new stage, and then it's gonna be x top 1 equals x y top 3, and this should solve the problem. So now I started with xd and xd, the values changed, and then the lines are plot, and then I have a new values of x top 1 and x top 2, which are the last values on the first stage, and then it's gonna do the looping again and again and again, and this should end when the line of the top section line crosses the x-intersect or gets larger than the x-intersect. And this is what I see when I do the run. I have 1, 2, 3, 4, almost 5 stages or whatever. Okay, and this doesn't matter if I change this to 0.99 and change the Q to 0.5, it's gonna work. And you see, it gets harder when the relative volatility is small, because you have hard or difficult separation. In this case, you would get very, very small space here for you to draw the stages, and it gets more difficult when you go this way. I'm gonna make it 95% so that it's not that bad, and I'll make it again to 2.5, for instance, because I need now to look at another point, which is calculating the number of stages. So I know now visually that I have 1, 2, 3, 4, 5, 6 and quarter almost stages, or one third. So I can ask Matlab to draw the or calculate the number of stages for me. So I know this is 1, 2, 3, 4, 5, 6, and this fraction, which is this distance, divided by the whole distance. So to do this, I know that the number of stages equals the number of loops that it did, because this is how it plots. Each two lines represent one loop. So I can have a counter here. I call I equals 0, and with each loop it will increase by 1. And then I can say that the number of stages equals the I, but this is not gonna be exactly right, because it considers the last stage as a full stage, but actually I have all of them except one plus this fraction. Or you can say that this is the total number of stages minus this fraction, whatever. You can say that. But I need to calculate this fraction to be able to, or this fraction, or this part divided by the whole thing, to be able to calculate the theoretical number of stages. And to do this, you need to have, I know x intersect, so I have no problem with it. And I know x top 2. It's gonna be there, but I do not know this point. If you check the values that you have for x, they are all the same. I know that this should be around 0.28 to 0.29, and this is gonna be 0.24 or something. But these all are 0.24, and this is what I did actually, because I asked Matlab to change the values with each loop to be equal to the last point in the previous stage. So I still need to have the value of this point, and to do this you can just create a new variable. You can say it x plot top, for instance, call it anything, and this is gonna save the value of x top 1. Okay, and then you can say that the number of theoretical stages will be equal to the I minus the fraction, which is gonna be the x top 2 minus x intersect divided by the x top 2 minus x top, or plot top, plot top. And then let's try. So it says that it's 6.3, and this is what I expected. 1, 2, 3, 4, 5, 6, and that's it. Now let's see when it is a hard separation. And I'll have a small alpha and high x feed, and when you do the run, you'd see that it is very big number of stages, and it's telling you that it is 19.5 stages. You can even get more difficult here. If I make it 1.2, you see it's very narrow space, and it's able to calculate the number of stages. Here you see it's 43 theoretical. Of course it's not logical to have such a separation, but what I mean that it's gonna get the number of stages very accurately, because it's not drawing with a pencil, so it's there is no problem with the thickness of the tip of the pencil or something, so it's doing the work itself. One other point I need to raise is when you do the work here, or when I did it, I had to do the calculations for each and every line that I plot on this stage. So, or on the plot. So I have here 7 stages, so I had to plot 14 lines for the top section. And to do this, I had to calculate them and do select data. It was very time consuming process. I had to go here, and you see there is 45 line, equilibrium Q line, and top stage AB, 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 and then the same for bottom stage. And if you want to add more, you had to add and then call it whatever name that you need to call, so you don't get confused with another line. So it's not the best thing to do actually. And let's say I have a hard separation like the one that we have here, and I have the alpha as 1.5 for instance. You would see that oh, I think the alpha wouldn't work this way. If I make it 2.5, you would see that the number of stages is it didn't reach this point because it's plotting 7 stages. It doesn't matter if these 7 stages are gonna end before or after the point that I need to stop at. So this is kind of working nicely, but you have to do the work yourself. You have to add the lines one by one by yourself to do the work. However, here you don't need to worry about anything. The code that we wrote here was only not exceeding 10, 11 lines, and this was able to plot 19 stages and calculate the number of stages for you, which is magnificent actually. So I'll stop here. In the next video, you'll see how to do the work for the bottom section. So I'll see you then. Goodbye.